The first stationary bike was developed by a London physician in the late 18th century. It was developed to exercise the joints of patients suffering from gout, rheumatic disorders, or other afflictions. Today, the modern stationary bike is all about helping people stay fit to prevent illnesses. On this stationary bike, magnets linked to a flywheel create tension that causes the cyclist to pedal harder, making the workout an uphill battle. Production begins with steel tubing for the base. A probe locates the center of the tubing. This reference point allows a computerized laser cutter to find the exact spots to cut assembly holes. With the assembly holes cut, the laser slices the tubing to the correct length. An automated system retrieves the part and transfers it to a holding area. Next, bolts are inserted to attach the completed base part to the main frame. Sealant is piped around the bolts as they're fitted. The three parts that make up the base frame are then arranged in a fixture and clamped into place. The fixture revolves. Then a robot welds the three parts together, completing the construction of the base of the stationary bike. The automated welder has two fixtures. On one side is the fixture for the main frame. While this is being welded, the next base frame is arranged on the other side. As this goes to be welded, the main frame that's just been welded is presented for collection. The welds and seams are then ground smooth, and any burrs are removed. The metal is then sandblasted, washed, and applied with a primer. After earthing the main frame, electrostatically charged resin and pigment is sprayed onto it. Once it's baked on, this powder coat will provide a protective finish. At another station, a press punches holes into posts for the bike's handlebar and seat. The holes are for adjusting the height of both parts on the final bike. Next up is the casting for mounting the handlebar to the post. Using a press, the top of the post is fitted to the casting. After a quick check with a rubber mallet, the assembly is set aside. At another station, 5 seat posts are aligned and locked into position. Then a stencil of sequential lettering is draped on top of them. An etching wand is then dipped into a chemical solution which is moved back and forth over the stencil. This burns the letters into the steel, providing markers for the seat's height adjustment. Here, holes for the axle are being driven into the bike's crank arm. After the depth of each hole is checked with a gauge, an axle is inserted into the hole that's then pushed into place using a press. The hole is measured from the other side of the crank arm to confirm that the axle has been set to the correct depth. The assembly is then bolted to a precise torque. The crank arm assembly is then locked in a lathe. In order to protect it from shards of flying metal, a foam sleeve is placed over the crank arm, while a tool machines the part that will eventually hold the bike's pulley. Here, the bearings are being assembled to a wheel hub. 2 bearings with a spacer are slid on a press. And after the hub has been heated in an oven, causing the metal to expand, the bearings and spacer are pressed into it. As the hub cools, it shrinks, ensuring a tight fit to the bearings. A retaining clip is then installed in the hub. Next up are the holders for the magnets that create resistance on the flywheel. Each one is placed in a fixture to check the dimensions. The strength of the magnets is checked in a tester, and if okay, 2 are inserted in each holder. Finally, a metal cage, held in position by the magnets, completes the magnetic field. Now all the sub-assemblies are complete. It's time to put the stationary bike together. First, the magnetic resistance unit is installed so that it swings from a bracket on the main frame. This bracket holds the computer board. The aluminium flywheel is then mounted to the axle, sliding between the magnets in the tension device. The flywheel hub is capped and then screwed in place. The torsion spring-equipped cover completes the stationary bike's tension system. After the crank arm and axle have been fitted, a bearing is then installed, after which it's on to the next station. Here, an alignment tool is placed on the back axle. Then an elastic belt with grooves is looped first around the small pulley on the flywheel, then the larger one on the crank arm. Another tool is inserted into the crank arm to aid the installation of the belt around the large crank pulley. Both installation tools are then removed. Next, 4 flat bushings are fitted into the handlebar post. These will make it possible for the handlebar's height to be adjusted. A label is then attached that has height indicators. Not only that, it also helps to protect the metal post from abrasion. The second crank arm is then bolted to the axle, which is tightened to a specific torque. Next up is the seat assembly. The seat stem is slid into the post and locked in position with the adjustment knob. Next to be fitted into the bike frame is the handlebar post, which has been fitted with the gear cable and communication wires. These are threaded through the post. Again, an adjustment knob secures it in position. The communication line is then connected to the computer board, and the gear cable is linked to the resistance system. After it's tested to ensure it works, it's locked in place with a nut. Next, a plastic cover is installed on the drivetrain. This will protect the rider's legs from the pulley system and shield the metal components from human sweat. For further moisture protection, a sealant is applied around a welded joint on the bike frame. Then the frame of the bike is encased with more molded plastic. Both casings are bolted to the bike. Next is a test. A microphone is attached with magnets to the axle, and the flywheel is spun at a high RPM. The bike is designed to operate as quietly as possible. The decibel meter confirms the noise level is negligible. The location of the magnetic resistance mechanism is set using a special tool. This calibrates it so that the handlebar computer can find it and display the resistance setting during cycling. Next, thread-locking adhesive is applied to holes in the crank arms, after which pedals are screwed in place, then tightened to a specific torque. The thread-locking adhesive bonds the pedals to the cranks, and again, keeps the moisture out. The frame can now be secured to its base. Its holes are positioned over the bolts on the base, and then it's locked in position with cap nuts. A metal guard is then installed that encircles most of the flywheel. It prevents contact with the edge of the wheel when the bike's in use. Once the trip computer has been mounted on top of the frame, the handlebar is slid into place. It's taken about 2 hours to make this stationary bike. And now that the work is done, the workout can begin. Smile, not far to go now.